morning student. Today we are going to discuss unit 2 topic multiple integral. So in your earlier classes 11th and 12th standard you have studied simple integration line integral, which is called as one dimensional integral. When we calculate line integral we get length of a line. Now today we are going to discuss multiple integral. Multiple integral in the sense it could be double integral, it could be triple integral. So simply we can just understand this. When we used to calculate one dimensional dx, dx integral, we get line integral. Now when you will integrate double integral, means dx and dy, you will get two dimensional space, which is known as area. And when you are going to integrate three dimension dx dy dz, you get three dimension, which is volume. Now let's see. This is a double integral area. You can see this is the area along x-axis and this is along y-axis. Region R we have to integrate over the limits x varies from a to b and y varies from c to d. Now we start with the function f, which is a continuous on a rectangle region R. A varies from a to b and c varies from c to d. Then we define double integral of f over r as this is r, f of x comma y dx into dy. Dx means you are integrating with respect to x-axis, dy means you are integrating with respect to y-axis, and limits you will follow. So we have, as we used to discuss partition in line integral in one dimension, you can similarly we can follow that in two dimension. Here we have a partition P1 for x-axis from x0 to xn, and P2 partition is along y-axis, which is from y0 to yn. Then when you will multiply these two partition P1 with P2, you will get here P, which is called partition P of region R. So you can see here region R, which is two dimension, it is broken into small regions, which is known as dx into dy. So you can see this is all the division of whole region into small part, differentiation and then integration. Now here we used to calculate lower sum and upper sum. Upper sum is the area of Rij into maximum value. This will be known as upper sum, and the lower sum will be the smaller values with multiply with the area of this. So that is like a topic of Riemann sum. We can see upper sum, upper Riemann sum, lower Riemann sum. If they are equal, then we will calculate that is the area under the that given particular region. This is a definition again of double integral. Similar, just we have discussed, it is just same like that. R is a region which is integrated from x varies from a to b and y varies from c to d. Frobenius theorem is there that if f of xy is a continuous throughout the rectangular region R, x varies from a to b, y varies from c to d, then this is the integral. And if you are changing the order of integration means if further like whether you are integrating first with respect to x or you are integrating first with respect to y, the integration will remain same in both of the cases. See here, if dx is written at first, that means you are integrating with respect to dx, and if dy is written at first, that means you are integrating with respect to y. So if you will change the order of integration, that means further you are, that means first you are integrating with respect to x or with respect to y, the answer will remain unchanged. This is about the first theorem, which is known as Frobenius theorem. Now let us see one example. We have to calculate area of f of xy, and this is the given diagram. This is the surface z and its equation is 100 minus 6x square y. As you can see, x is varying from 0 to 2, y varies from minus 1 to 1. This half portion is below the region, half portion is above the origin. Now this figure displays, so obviously if we are finding area, then this will give you a volume. Now let us put the value of f of xy, which is 100 minus 6x square y. First we are calculating area with respect to dx. When you are calculating area with respect to dx, at that time y will be taken as a constant and x will be integrated. Now 100 is constant and derivative of integration of constant will be x minus x square. So apply the formula x raised to power n integration is equals to x raised to power n plus 1 upon n. So this will be 2 plus 1, 3 upon 3, and 6 by 3 cancel, this is 2x cube y. After calculating integral, we have to put the upper limit minus lower limit. Now upper limit for x is 2 and lower limit is 0. So it will be 100 into 2, 200 minus 16 into y. You will get this after taking integration with respect to x. Further, we have to take the integration with respect to y. 200 is constant, so integration of constant will be y. With respect to y, it will be y, and it will be y. Add power 1 plus 1, 2. It will be y square upon 2. 16 by 2 is 8. Now put the upper limit, lower limit. All in all, you get this is equals to 400. So this is the value which we get first taking derivative with respect to x. Now let us change the order of integration. Earlier we took derivative with respect to x first, integration with respect to x first. Now we will take integration with respect to y first. So again 100 is a constant, integration of 100 with respect to y will be 100y minus y has power 1, it will be y square upon 2. 2 and 6 cancel, it is 3x square y square. Put the value, y is equals to 1, y is equals to minus 1. This is 100 minus 3x square. Put the upper limit which is 1, put lower limit minus 1, simplify. You will get it 200. After that 200 is a constant. Again integrate this with respect to x. You will get 200 and x. Put the upper limit 2, lower limit 0. 200 into 2 is 400. So you can see, irrespective of order of integration, the value in both of the cases is 400. So Fibonacci theorem, which is first theorem of calculus, is satisfied. Now this is our example number 2. Find the volume of a region bounded by this elliptic paraboloid. You can see this edge. This edge is a kind of elliptic paraboloid, and the area of function given is 10 plus x square plus 3y square. X varies, x is along this direction, x varies from 0 to 1, and y is along this direction, y varies from 0 to 2, and we have to find the volume of this rectangular region. So to find the volume, we will do double derivative, this double integration over the region R. Here y ranges from 0 to 2, x varies from 0 to 1, and when you are taking integration with respect to y, x will be treated as constant. Obviously 10y plus x square y. Now this is y square. When you will find integration of y square, it will be y cube upon 3. 3 and 3 cancel, this is simply y cube. Now put upper limit which is 2, lower limit which is 0. So this will be lower limit definitely 0. 10 into 2 20 plus 2x square plus 8 into dx. Now we will proceed for integration with respect to x. 20 is constant, integration will be 20x. X square integration will be x cube by 3 plus 8x. Now again put upper limit, lower limit is 0. It will not affect. Just put upper limit. You will get 86 upon 3. So this is the volume which we get when we calculated first integral with respect to y, then with respect to x. So you got the volume for this particular elliptical paraboloid. Let us see next example. Here we have given find the volume of a prism. This is a kind of a prism, and the base, whose base is a triangle in the xy plane. That means the base of the prism is placed. This is x-axis and this is y-axis. This is our prism base, and its base is in this xy plane. You can see this is a triangular portion which lies in xy plane, which is bounded by x-axis and y-axis. Now this equation will be obviously y is equals to x, x ranges from 0 to 1, and top lines in the plane, this top is in this plane, right? This is the top area of the plane, and we have to find the volume of this. So what we will do, we will just put the value here, and we will integrate along with respect to x-axis and y-axis. Now this is an order of integration. This is called horizontal strip, this is called vertical strip. If you are taking x varies, y varies from 0 to x, x will varies from 1 to 0 to 1, similarly for y, right? So we will find this integration for any x between 0 and 1. Y may vary from y is equals to 0 to y is equals to 2. So this is 3 minus x minus y dy with respect to dx. So what are the limits of y? Y is varying from 0 to x varies from 0 to 1. You can see from this diagram here, y varies vertically, x varies horizontally. So y starts from here, this is y is equals to 0, it goes up to this line where the limit of y is up to x. So y varies from 0 to x and x varies from 0 to 1. Let us integrate along using this order. First we will integrate with respect to y. 3 is constant, it will be 3y. X is constant, it will be xy. It is y raised to power 1, it will become y square upon 2. Then further put upper limit and lower limit. Upper limit of y is x and lower limit is 0. This will be 3x minus x square minus x square by 2, which is minus 3x square by 2. After taking integration with respect to y, we will take its integration with respect to x. This will be x square upon 2 minus x cube upon 2. Put upper limit minus lower limit, this will become simply y. So this is the value 1 which get by taking vertical step. Now you can check this by changing the order of integration. Now when the order of integration is reversed, which means we are taking this. Now here x is varying from y to 1. This is the lower limit of x, which is this line x equals to y, and this is the upper limit of x, which is x equals to 1. So x varies from y to 1 and y varies from 0 to 1. Let us put this. So you can see here first x is written, that means we are integrating this function with respect to x. Lower limit of x is y and upper limit is 1. So integrate, this is a constant 3x minus x square upon 2 minus xy. Put lower limit, put upper limit, 3 minus 1 by 2 minus y minus put upper limit 3y plus. Simplify this term, add same terms. 3 minus 1 by 2 will be 5 by 2, minus 5 minus 3y will be minus 4y, minus 1 by, y square by 2 plus y square will be 3 by 2 times y square. Now integrate with respect to y. This will be 5 by 2 times y minus y square, 2 times y square plus y cube by 2. Put upper limit of y, which is 1, lower limit, which is 0. Simplify, you will get here 1. So you can see on changing the order of integration, you get that answer is same. Thus two integral are equal as they should be according to the first theorem of calculus. So this is the multiple double integral. Thank you.